Now in this video, let us look at adjoint. Adjoint is actually the transpose of the matrix of cofactors of A. Okay, so basically what we have learned before, which is finding the cofactors, to make it an adjoint, to change the matrix in the form of adjoint, we just simply transpose the cofactors. So let's try to look at this example. So just imagine that this is the matrix and they want you to compute adjoint A. ADJ stands for the shorter term for adjoint. So compute adjoint for this. Basically, to compute for adjoint, we need to calculate for minor and cofactor first. So this is what they did here. So for each of the element, they calculate their minors and cofactors. So as you can see here, this is example M11, which is -4. So this is the formula is -1 ij, which is 1 1, and the element that we need to use to calculate for minor is every element except those within its column and row, which is this. So that's why they have this here. So they just calculate everything and they get this. So 10 is the cofactor for for element 1 1. So as you can see, they substitute here. Alright, so Cij here stands for the cofactor 10. So they did it for each of the element, and so this is the calculation, and this is what they get. Alright, so to turn it into adjoint, simply transpose the cofactor. So remember, the transposition process consists of changing columns to row or row to column. So for example, 10 43 2 in the first row become 10 43 2 in the first column. 30 17 6 in the second row become the second columns, and the third row become the third column. Alright, so that is how to find the adjoint. Okay, so I hope that we can do this together. Alright, so let me put everything into the math type. Okay, so I have copied down the question and make some calculation. They want us to find the adjoint of matrix A. So what I did is, now for us to get the adjoint again, let me reply, we'll need to find the minor and then get the cofactor after that, then we'll get an adjoint. So first, from the A to become minor, so basically we'll need to calculate for the determinant of the minor for each of this element. For example, for A11, the minor should be -6 times -6 minus 0 times 7, then you get 36. Okay, for A12, right, where this is the column and row, the calculation will be 7 times -6 times minus with 0 times 6, where you get -42, and so on and so forth. So when you did for all of the elements, this is what you'll get for minor. After that, we'll need to change this in a form of cofactor. Now, as I said before, to change minor to cofactor, it is just a matter of positive or negative. And as we know, for the first one, it is for A11. So negative, for the form, based on the formula, we know that it is -1 1 times 1. So -1 to the power of 2. So you will get 1 positive. So for the second one, for 1 2, right, it is -1 1 plus 2, so negative 1 to the power of 3, so you will get negative 1. So basically, if you try to make it simplify, it is actually, you should get negative 1 here, positive, negative, and then you had negative, positive, negative. It should be in this sequence. So you have first positive 1, and then negative 1, and then back to positive 1, and then we have negative 1, positive 1, and then negative 1. So we have positive 1, negative 1, and positive 1. So this is the value that need to be multiplied with minor later. So we just simply do it like that. So 36 multiply with this, you get back 36. Okay, so negative 42 multiply with negative 1, you should get positive 42. 85 times with positive 1, go back 85, and then a negative 82 with negative, you get positive 82. Negative 12 with this positive 1, you should get back a negative value, so negative 12. Negative 68 with negative 1, you'll get 68. 24 with positive 1, 24. Negative 28 with negative 1 should become positive. And then lastly, negative 51 with positive, you should get negative 51 back. Now this is the cofactor. Now that we have this, next thing to get the adjoint is simply change the row to column or column to row. So for this one, let's change column to row. So 36, 82, 24. So 36, 82, and 24. The next column is 42, negative 12, 28. Right, 42, negative 12, and 28. And lastly, 85, 68, and negative 51. So that should be the answer, right? The adjoint for A, right? So wait, let me see. Right, there you have it. And that is the answer there. So that is the adjoint, right? And we are not just calculating this for nothing. It will be used later in further calculating tools, calculation in matrix. We are going to use adjoint. We are going to use determinant and so on later. Right? So thank you.